Hey, welcome to another tutorial here. In this tutorial, we're going to be creating one of the shots that I made for my banana video, just like an experimental little animation thing I made a while back. It's going to be this shot here where there's this sort of like flowy banana RBD. It's kind of liquidy, kind of noisy, but it's RBDs basically. But it's going to be driven by a flip sim. So we're going to be using a little bit of mops, and yeah, it's actually it's not really a super difficult setup, but there are a few steps involved. So I might just break this into two tutorials. We'll see how long it gets. But without further ado, let's get started. So let's put down a GeoNode, and we'll call this sim. Okay, and let's put down a box. Oh, not a full body. Well, a box, I said. Thank you. Okay, and let's make it like 5 by 5, and then let's make it kind of thin. Let's do like 0.15, and then cool. Let's do a points from volume, and let's make that like 0.04. Okay, something like that. Okay, so we're going to feed this into a flip sim. So the first thing we're going to do is we're going to build our flip sim. We're going to create all our velocities using our flip sim. And then we're going to use that to drive the motion of an RBD simulation so that all these bananas or whatever you want to use collide with one another. Okay, so before I feed this into a flip sim, I want to set up some custom velocities because I want to create these like splashes that kind of pop on and off. So we can do that pretty easily. So let me just, come here and okay, so what I want to do is I want to select this guy here, put S on the keyboard and blast it away. So let's move this. And I want to delete non-selected so that I have this. And I want to scatter some points across this. Okay, and the amount that I want is not 1,000. And I want to turn off relax iterations for sure. So what I want like 2 or 3, but I want it to be random every frame. So what I can do up here is I can go rand $F. So what that's going to do is it's going to randomly create a few points, but I want to fit that. That's going to give me a value between 0 and 1 every frame, but I want to fit that between a certain number. So if I go fit and then I go random $F, I can fit that value. We know that the random is going to give us a value between 0 and 1. So it goes from 0 and 1, 2, and then I'm remapping the values here, 1 and 3. So instead of being 0 and 1, it's now between 1 and 3 every frame. And let me, maybe I can turn on lit spheres so you can actually see this a little better. So depending on which frame it's at, it's 0, 1, 2, 3. And let me change the seed here to be $F. So every frame, the seed changes too. There we go. So you can see I've got between 1 and 3 points that shift every frame. Great. Okay, that's cool. Now I don't want this to be, this is going to be like way too fast. So I want to put a switch here. This is a little trick, and put a null here. And I want the switch to be, I want this basically to only happen every 4th frame. So right now it's happening every frame. I want this to be have like 3 frames with nothing on it, and then on the 4th frame it pops on, and then 3 frames with nothing, on the 4th frame it pops on. The way I can do that is I can do the $F, which is my frame number, and then use the modulo function and 4. So what that's going to do is, so I go nothing, 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 and then on the 4th frame there's something, and then nothing, 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 nothing. 8th frame there's something. So basically every 4 frames, it gives me anything that's like divisible by 4, it'll give me, it'll switch to the first input. And then if it's not divisible by 4, it'll switch to this null, which is just nothing. Okay, cool. So the next thing we're gonna do is, I guess I can turn off I can go back to points. I'm gonna create some normals here. So let's just put down a attribute create and normal, and it's going to be a vector, and I want it to be pointing up in Y. So let me go to there. You can see. So I've got my normals. They're pointing upwards. Great. Okay. I also probably want a p-scale for later. So attrib create. Let's go p-scale. It's a point. It's a float. Just put 1 for now as the value. Okay. The next thing I want to do is I want to create some lines. So what I'll do is I will create, put down a line here. And let me turn this off. And let's give it like 100 points. Okay. And then let's put a mountain stop on it and kind of noise it up a little bit. So, okay, I need to turn this, because I need to turn this noise along vector off, and then I can increase the amplitude a little bit here. So something like 0.58, and let's maybe go to the noise pattern, bring the element size up. I don't know, something like that. Just kind of trying to give myself little wiggly line here, something like that. I don't know. Let's do 2.73. How about that? And then offset of 2.2. I don't know, something. Doesn't matter that much. Just kind of play around with it. Just get so your line isn't like totally straight. Okay, and then let's put down a match size to get this to be justified in the Y minimum. And I want this to be, move this a bit. Oops, move over. So this point is like right on 0.0. Something right around there. Okay, great. And then I can put this, let's put this into a mops instancer. Great. And I want the distribution to be radial, like this. And I probably want, I don't know, maybe like 4. Okay. And then let's do distribution. Let's do like, let's see, no, scale. Where's it at? Come into uniform scale. Yeah, I want these to be more like this. And then maybe let's put a mops randomize beneath it. And let's randomize the scale. And I want it to be from minimum value of 0.4. Let's go max value like this. Something like that. I can change the seed a little bit. Okay, and then let's also randomize the where am I at? Orientation. And let's change these all to 0 really quick. And let's see what we got here. Let's move it like that. Just kind of giving myself a little bit of something like this. So basically I'm going to turn this into a velocity. So this is going to be like a splash that's going to happen within the water. Okay. And then I've got this now, and it's packed geo. I'm going to unpack it because I want to, because I need to. Oh, the other thing I need to do is up here, I need to put down an orient along curve. So what that's going to do is I need to turn off up. Basically, I want to give myself some normals. So basically, that's going to give me normals that point along the path of the curve. So I'm going to turn that into velocity here in a minute. So I should still have that. Yep, great. And then let's put a null here. Let's put this, call this out curves. Straighten this up a little bit. Cool. Okay, and then I want to copy this to these points. So copy to points. I want to copy this geometry to this here. And these are aligned the wrong way. So let me transform them. They should be aligned in the Z direction like this. There. So now I've got these things here, and they're going to be every 4 frames, they're going to appear. Cool. It's doing what I want. All right, and I probably want to adjust the P scale here because these are all exactly the same size right now. So let me go to P scale. Let me go attribute adjust float, and what I want to adjust is P scale. And let's do multiply, and let's do a pattern type noise, and then let's just do like a minimum value. Let's do like 2.34 for the max, and the minimum, let's do like really small like that. And then let's do let's come to our noise pattern. Let's make this like 2.44. I don't know. Just give it some randomness so that they're not all the same size. So cool. We've got our little splash things happening. Great. Okay. The next thing I want to do is I want to turn my normals. So I've got my normals here. I want to turn that into velocity. So I can just do attribute remap, attribute remap. There we go. And the original name is N, and the new name is V. Okay. And let's see. We've got N. Why is this not working? We've got N here. So actually, I think the attribute remap is not going to do what I want it to do in this situation because I think it only works with floats maybe. So I'm just going to use a wrangle. It's just going to be a lot easier to do it this way. So sometimes it's just easier to type a little code. So we're going to go V at V, so which is our velocity, which we do not have yet. So we're going to tell it that V at V equals at N, which we do have. Okay, so I need a little comma thingy there. Okay, so now all of a sudden, so we have our N, and now we've got our V. Where'd it go? I just had it. It was just working. That's strange. Okay, so I've got it there. V at V equals N. You can see my little V lines there. They're kind of small, so I actually want to increase this. So let's just multiply it by like 30. Okay, so now we've got some like very strong velocity going along these curves. Okay, that's what I want. I'm going to put set V. That's what I'm going to call it. Okay, the next thing I need to do is I need to convert this to a VDB because otherwise Houdini won't be able to read it in as a velocity in the flip sim. So let's do a VDB from particles. And that's gigantic. I don't want that. Let's do voxel size, or let's do the point radius scale 0.09. And then let's bring this down to 0.01, something like that. Okay, and then I want to take some, right now it's just a surface, and I don't want that. I want to rasterize a point attribute. An attribute is V, and the VDB name is going to be vel. Okay, so now we have our vel, and let's put down a null and call this out vel. Great. Okay, so let me just put a little box around this guy here, clean it up, and just call this create velocity and make it green or something. Crat velocity. Create. There we go. Got to spell it right. Okay, so now we've created our velocity thingies. Let's go back and we're going to design our flip sim now. So it's going to be really simple. So we will just take this guy here and we're going to put down a DOPNet. Plug this into the first input. We're going to dive in and we'll put down a flip solver. So we need one of those. We're going to need a gravity. Put that there. I don't know what that blue thing is. Okay. And then we need a flip object. Put that in. Okay. So the first thing we want to do is set up our flip object here. So let's, we don't want a surface SOP. We want this to be a particle field. And the field that we want is, let's do, just grab this points from volume, copy it, and then come back and paste it here. Okay, and then, let me go back to frame 1. That's why I'm not seeing anything. For the guides, let's come to particles, turn off the sprites, change it to, not spheres, change it to particles so I can actually see what the hell I'm doing. Okay, and then I want to make sure that my particle separation and particle radius scale are the same as my, my points from volume thing. So I can just go particle separation, I'll go copy parameter, come up here, and I'll go paste relative references. And then I want to go particle radius scale, copy parameter, and up here we'll do, I think I need to add a scale attribute. Yep, paste relative references. And I want to make sure I come back in here and change this to 0.04 again to get back to where I was. And then I want my grid scale, I want it to be like 1. So it'll give me a much finer result. The other thing I want to do is I want to change my boundaries here. So right now my flip boundaries are like gigantic, and I want this to be like contained to this guy. So let's look at our box here, and it's 5 by 5. So I'm just going to come back here, and I'm going to change this in my volume motion. We'll go to collisions, or box size. We'll go 5 and 5, like that. And then I want my box height. Let's just bring this down. Oops, like that. And let's kind of bring this up a bit to where, let's look at it from the side view. Hit space 3, something like that. Okay. And then I want to, let's just raise the top a bit, just in case. And then if we come up to the flip object again, I can hit closed boundaries, and I want everything to be closed except for the Y plus, just in case it goes out of bounds. Okay, and I want, so this way it should collide. So if I just hit play, it's doing something. So it's falling down, but it's not moving. And I wonder if that's because I need to move, let me try moving this down a bit. There's no forces. Let me put a pop force and just make sure this is working. Put this right here. Let's put an amplitude of 1 and just see what happens. Okay, so it is working. We've got our flip sim. It's doing something. Great. I think I probably didn't need to move this down, so I'm going to move it back up a bit. There. Okay, so we've got our flip sim basically in there. There's a few other things I want to adjust first. So in the flip solver, I want to, under the substeps, I want to change the time scale to 0.5 because I want this to move slower. Under the particle motion, I'd like to add an ID attribute just in case. And then under reseeding, this is important. You want to turn off reseeding particles. So if you leave the reseeding particles on, it's going to try to maintain a consistent distance between every particle by spawning new ones. So you see right now, it looks like the particles, there's not that, they're kind of sparse, but then as soon as I hit play, they like thicken up. And that's because this is trying to create new particles so that there's a consistent amount of particles. I don't want that because we're not actually going to be creating any water. We're just going to be using these points as points to copy some geo onto. And I want the point count to remain consistent. So I'm going to turn off reseed particles. So now it should just look like that. So that's pretty important that you do that. And then under the volume motion, let's see if there's anything. I'd like to leave this at splashy, definitely. And then let's see. In the solver, I think everything else should be fine. Okay, so the next thing I'd like to do is I want to bring in my my velocity that I created earlier. So let's go to outvel. Let's copy that and come back, and let's put down a pop advect by volumes. And oops, why'd that go there? And I want this to go into the volume velocity tab, or a little dot there. And the SOP that I would like, I want to just paste my outvel. And yeah, let's just see if that works. Let's just try it. Hit play. There we go. So we're getting these splashes. Every few frames, we got these splashes. Very nice. That's doing exactly what I want. Now, I think these splashes are going way too high. So maybe I'll change my velocity scale to be like 0.45, like that. That's better. Cool. Okay, but I want a little more motion than that. So I want some general waviness. So let's put a pop force, and we'll put this one into the particle velocity. And let's see, let's do the amplitude of 1.3, maybe a swirl size of like 5, just kind of give it like big broad waves. And let's just see what that looks like. Cool. So I think that's doing what I want it to do. Cool. So that's pretty much it for the flip sim part. So we can probably just cache this out, and then we'll come back and we'll set up the RBDs here in a second. So let's cache it out. Let's go to let's do like a DOP.io, and let's put this here. And the DOP node is flip object 1. Great. So we've got that. And then I want to choose particles. There we go. Cool. So that should be working. Let's see. Let's just test it. Yep. It's doing what I want. Very good. Cool. And I think maybe I want these splashes to be a little bit stronger. So let's try 0.55. I want them to go maybe a little higher. Let's see how high these are going. It's pretty good. So we're going to get in really close here. Let's see, maybe 0.65. Let's try that. I think maybe that feels a little better. Maybe some of those are going too high. Let's do 0.6. Let's see. Sure, let's call that good. No, I'm going 0.55. I'm wrong. Okay, cool. But adjust it to however you want. And then we can cache this out. We'll call this flip sim. And let's make sure that we have, I've got our ID, a P scale, V, cool, okay. And I'm just going to save the disk. And then we will come back and do the RBD part. Okay, so we've got our flip sim cached. You can see it here, can scrub through, cool, looking great. Very nice. I'm liking what's happening, and I can retime it later if I want. The next thing I want to do is I want to add some color based on the velocity here. So let's do a wrangle, and let's just create an attribute called speed. At speed equals the length of V at V. So we're basically just measuring the length, the magnitude, or oops, got to put the right type of semicolon there. So that just gives me an attribute called speed. And let me switch to my IF basic thing so I can see my my speed here. So I've got a speed, it goes between 0 and 2. Looks like the highest, yeah, 0 and 3 maybe. Yeah, pretty much 0 and 4 maybe is the highest. Okay, so let's now put down a color node. And we want to do a ramp from attribute, and the attribute is speed. And let's do white water. And my maximum is 3, maybe, I think it's maybe 4. Let's see what that looks like. Cool. Maybe change this background to dark so I can actually see. That'll help. Cool. So this will allow me to colorize my RBDs or my particles later to be more to have them change color based on their velocity. Okay, cool. So let's put down a null. Let's call this out points. Great. Okay, so we've got our velocity. We don't need that anymore. We've got our points. This is going to be driving our RBD simulation. Now we need to bring in our model. So let's put down a file node. Actually, let me do this in a different geo. Let's put down a geo, and we'll call this banana. Banana. All right. Is that how you spell banana? I don't know. Okay, and let's put down a file. And I believe I got my banana off of Megascans. So let's see. Let's find it here. Let's go D, Dropbox, 3D, assets. I think it's under textures. Let's go Megascans. And then I think I put it under assembly assets, fruit, banana. There we go. And I want this, let me turn off show sequences as an entry. So I want to do, I'm going to have one banana that's low res and one banana that's super high res. So I'll simulate with the low res one, and then I will use the high res ones come render time. So there's the file. Let's transform this to like 0.1 of its size. And then let's do a match size. Let's plug that in here. Let's get that. Let's do the target size. Let's do 2, 2, 2. Is that, maybe that helps? I don't know. Let's do scale to fit. And then, yeah, so that should be my low res banana. So let's put a null, call it out low. Okay, and then I want to copy this. Let's make these both black. And we'll call this, so this one is banana low. We'll call this one banana high. So we'll come here and let me just hide other objects. We'll come back and we'll find the level of detail 0, which is the high res one. Okay, great. Let me copy this, and I think I need to change this. Let's call this out high. Okay, great. So let's come back. Let's turn these off. Let's come back to our sim. Let's use an object merge. And the object I want is this out low right here. And let's do copy to points. And I want to copy, let's make sure I turn on pack and instance first, actually. Geometry, points. Boom. Okay, so suddenly we've got a shitload of bananas, and they are doing exactly what the water's doing. So that's cool, but they are all aligned in sort of weird, they're kind of aligning towards their velocity a bit, and they're not actually colliding with one another. So you can see they're intersecting because they're not RBDs yet. So we're partially there, but we're not all the way there. So something I want to do is I want to create a MOPS randomize, and let's just randomize orientation. Cool. So that should help it feel a little bit more random. So this is before, this is after. Cool. So that's nice. That helps. the other thing I want to do is I want to scale these down. So right now they're all like intersecting, and for a RBD simulation, they cannot start intersecting or it's going to be like totally messed up. So what I'll do is I'll just put, not a trace, get out of here. Let's put down a transform here, and let's make these like half the size. So now pretty much, I don't think any of them are intersecting, right? So we're going to scale these up in the simulation so that they start not intersecting and then they scale up to eventually collide with one another. And then finally, before we go into the RBD sim, we need to put down an attribute delete, and we need to delete a few attributes. So we need to delete scale, scale, orient, p scale. Let's see, let's just come in here. Let's just scale, probably speed. Let's delete color, right? Okay, so I think that's it. So I think mainly orient and scale and p scale, sometimes they mess up. They will mess with the RBD simulation. Okay, so let's now put down another .NET. Plug this in here. We'll dive inside, and we want a rigid body solver. Plug that in. And then we need an RBD packed object. RBD packed object. Great. Put that there. And the RBD packed object, the initial state should be, let's see, we don't want SOP, we want first context geometry. So there we go, we've got that. And then we want to overwrite some attributes here. The attribute we want is V. So we already have our velocity on these. So that if we just hit play, let's just see if that works. It should be moving exactly the way that, that the water was before. And I'll just do a flip book here and pause the recording. Okay, so I ran a few frames in this little flip book here, and you can see it is working. So they're now dynamic, they're following the motion, but they're way too small. And I want to scale them up so that they fill up the space here. And I'm probably going to want a collider too to kind of keep these in the bounds. Let's do that. So first, let's build our collider here. So if I come up, I can, let's see, why don't I take it from this box? We'll start here. Let's just put a null. See it. Let's grab this, hit enter on the keyboard, or T on the keyboard, transform it up like that. And then let's do a poly extrude. And let's just extrude this whole thing outwards like that. And then let's take this guy here, put another null. Let's do a Boolean. So we want A subtract with B. So let me actually transform this here. Come back up and just template it. And then let's do scale. Let's increase it in the Y. And then for Boolean, let's see. Cool, there we go. So now we've got this collider. Let's see. This should be, yeah, that seems right. Right? Yeah, okay, so let's use that. And let me just make sure I've got my points from volume there. Maybe this guy can come up, or let's just grab this whole thing and transform it. Let's go spacebar 3. I want this to be like, what the hell? Why is this only transforming the top part? That's strange. I don't want that at all. I want to move this whole thing up. What the fuck? I'm not sure why this transform is transforming the top. That's super strange. It shouldn't be doing that. So it might be a viewport issue. So let me go new pane tab, viewer, scene view. Let's put down another transform. Let's zoom out and let's see. Yep, so it was just a viewport issue. Okay, so let's just go to our side view here. And let's move this up so that it's like almost at the bottom there. Okay, maybe just a little bit lower. Okay, and then we'll put down a null, call this out collider. And then we'll go back to our DOPNet here. And let's put down a static object, put down a merge this guy here. SOP path should be our collider. And there we go. Okay, so that should hold everything in there. That's great. And let's turn off display geometry. And then the next thing I want to do is I want to make sure I scale these up. So I can just do that using a MOPS transform modifier. And let's just put that in, here to the pre-solve. And what I want to do is just put 1.2. Now, the one thing to be aware of with this MOPS transform is that since this is inside the DOPNet, it's going to apply this scale every frame. So it's going to increase the scale by 1.2 every single frame, infinitely, unless I tell it to stop. So I don't want it to do that. I only want it to go a few frames. So I'm going to keyframe this activation, or better yet, I'll just do $F is less than 7. So that means if the frame number is less than 7, continue growing. If it is greater than 7, stop. So that should do it. And then let me just put down a pop color here, because I'll just colorize these again. I'll use Vexpression, and let's do color type ramp. We'll do white water, and ramp we'll just do length of V at V. And then we'll just increase the range to 4. Okay, so let me just run a flipbook, and we'll be right back and see what that looks like. Let me zoom in here so you can see. Save it. Cool. Okay, so I simulated a few frames here, and it is working, but there is something I forgot to do, so I'll show you here. So it's working, but these aren't really like going up as high as I want them to, and I think that's because I forgot to check this inherit velocity from point velocity tab in the initial state under the RBD packed object. So let's try that. The other thing I'd like to do is I want to come to the bullet data, and I want to make sure that I've changed this to create convex hole per set of connected primitives. I think that should, let's see, is that gonna break my computer? Probably. Shit. Shouldn't have clicked the show guide geometry. Never click show guide geometry. Okay, great. And then I think that's it. Let me try resimulating that again, and we'll come back here in just a sec. Okay, so I ran a few frames here, and it's working as expected. One thing that I realized that was totally messing me up here was it wasn't actually, so yes, it is important to have the, where is it at? The inherit velocity from point velocity thing, but the thing that was really messing me up was in my static object, you need to change this from convex hull to concave. That was what was messing me up, because it was treating my my cube thing like it had a lid on it, and like it was trying to like contain it inside this convex hull. So it needs to be concave to tell it that there is like a hole inside of it. That was really messing me up. So great. Let me turn this off. So what I want to do, so I've got this going here. It looks nice. It's obviously, I think it's going a lot faster than I want, but I'm going to retime it after the simulation anyway, but the motion is looking good. Okay, so there's a couple things that I want to adjust here just for the sake of making things run faster and showing you a different method that I think works a little better. for me anyway. So first thing I want to do, let's come up to this box, and instead of making it 5 by 5, let's make it 3 by 3. So we have less of these guys here. Wait, why did that go with 4.8? Go 3 by 3. And then we'll need to come into our flip sim here, and we'll need to adjust the bounds here. Let's go 3.1 and 3.1. Okay. And then let's hit spacebar 3 on the keyboard, and then just make sure, try to make this even so that it's like the same amount of space there and there. Okay, cool. So we've got that. Let's come back up. And then for our DOP import fields, that is taking the information from our flip sim, instead of having it just at the default or particles, let's go flip fluid, because I want to get this surface and this vel as well. And then what I want to do, so if I middle mouse click, you can see that I now have my velocity volumes. I want to blast those away and separate them. So let's come up here and vel X, vel Y, and vel Z, and then hit delete non-selected. So if we middle mouse click, you can see all we have is velocity. And let's just put another null over here, and we'll call this out vel. Oop. Vel. Okay, cool. And let's copy that. No, I want out vel. Why is it doing? Oh yeah, because I already have one over here, out vel. So we'll just call this out vel 1. Yeah, that's fine. Whatever. Cool. And then let's go into our DOPNet, and let's put down a pop advect by volumes. Plug that in there, and the SOP we want is this thing that we just copied, which is out vel 1, and I want the velocity scale to be 1.5. Let's try that. And the advection method, let's go trace midpoint. Okay, so in the RBD packed object, we can just turn off this overwrite scale attribute, or this overwrite velocity attribute thing. We won't need that anymore. I found this method worked a little better just using the advection. We've got our static object right there. Cool, and it's dynamic because it's all procedural. So when I adjusted the shape of the cube, the first one, it adjusts that. And let's come up here. Let's go to, let's check this out. And let's make sure if we show that, it's not colliding. Okay, cool. Great. And let's actually move this up a little bit, because I think if we look at this, these are going to, oh, why is it simulating? Oh yeah, because I need to, so if I go like that and show where this actually lands, I think I want my collider to be roughly the same there. So let's plug a transform in here and just bring this up to like there, just beneath it, like that. So it's going to fall a little bit, and then it'll land roughly on my same collider. Okay, cool. Let's test that out. So we've got our RBD thing here. Let's put down a DOP import. And I want to do this as my DOP network. And then I want to make sure I'm only importing my RBD packed object 1, because otherwise it'll import my collider as well. I don't want that. And then let's do create points to represent objects. Actually, I don't think I need this path. I think I just need it to say RBD packed object 1. Yeah, there we go. Okay. So we want create points to represent objects, because if you fetch geometry, it'll get all the geometry, and you're going to have to cache all of that geo, and that's not good. It's going to take forever. So we want to create points to represent objects, and then we want to transfer attributes. I think we want P. We want, let's try a name, definitely V, definitely W, pivot, orient. I think those are ones we want. We'll come back to that. But for now, let's just see what this is doing. So if I hit play, it should go. I'm noticing that there's a little bit of a glitch here. That's kind of strange. Why is that? Well, let's come back in here. In my rigid body solver, in my RBD packed object under the bullet data, instead of concave, yeah, we'll go convex hull. And I want to make sure, let's show the guide geometry, see what that looks like. It's going to take a second. Yeah, so you may need to lower this number because I think the default, let's see, the revert to defaults is like high. Yeah, it's 0.02. So that doesn't look anything like a banana. Let's go 0.001 to have it kind of shrink wrap to create a more accurate version of that, which will make it go a little slower, but it's still going to be faster than using concave. And let's turn off show guide geometry because that's going to be really intense. Okay, and so I think the problem might be with my collider here. If you see these points, they're really close to the edges there, and that might be creating some conflict. So let's first let's get rid of this guy and just come back up to the Boolean, or let's just template this out collider and not this guy. Let's come back to my points. Okay, and let's just make this. Well, okay, let's. Damn it! What am I doing here? Let's template the. Okay, and let's just try to make this a little bit. Maybe just increase the uniform scale a little bit so that it's just a little bigger, so that maybe those aren't conflicting. Let's see if that helps. Let's come back down to this. Let's hit play. Hopefully nothing falls off the side. Looks like we've got some things coming out the bottom here and the side. What is the deal with that? Okay, so I think I found the problem. If you look at my points from volume up here, from the top view, that's where they are. But then after the flip sim, they move a little bit. So the collider, if you template it, it's actually like off center a little bit. So like these points here are really close to the edge and much closer than these ones because it's starting with points intersecting. So if you come down here like this, you can see these first points here are like almost intersecting. So I think that's probably creating a problem. So I might want to just try to manually adjust this to be like a little bit like that. Try to just get it to be a little more, and maybe even let's just increase the size just a bit, just to make sure. Okay, so that should be good. Let's try that again. Let's come down to our dot import field, and let's just hit play. See what happens. Okay, so I think it's working a little better. Cool. So one thing we can do, so I just did this while it was paused, but we can put down a transform pieces. And then what that requires is rest points. So let's put down a time shift and just middle mouse click. let's bring this back to 1. Make this unlock it so that it's just frame 1, and then plug that into the rest points, plug the template points into this one, and then plug the geometry to transform into this guy here. So then we can kind of see what's actually happening. If we zoom in, so they're all scaling up, cool, getting like gigantic. It is working, cool. But I think maybe my bananas are like way too huge. So I might want to come back and do, change my mops transform. Oh, come on, why did you freeze? Oh, because I have this collision guide on. Maybe make this the first 5 frames. I don't know, something like that. See what that does. And then let's try this again. So let's just simulate it, see what happens. That seems a little better. So they scale up, but they're not getting too huge. And then I'm not seeing a lot of advection happening right now. I wonder why that is. Let's make sure I'm transferring in my DOP import. Let's transfer color too, so that I can get my, let's just put CD, because I think I have pop color here, right? Yeah, should be doing something. I've got my velocity thing here, or my pop advect by volumes. Let's try changing this from update force to update velocity and see what that does. I think that's how I did it before in my previous version. Let's see what that does. Okay, I'm not seeing the color attribute coming through. That's okay. But okay, now we're getting these little explosions. It's working. Great. Nice. Great, okay, so that's working, but I do want to I want to help myself visualize what's happening. So after the DOP import, we'll just do another, let's do this little trick. So wait, I do have the color information there. Why is it not transform pieces? Oh, because in the transform pieces, you have to do attributes to copy. There we go, that's why. Okay, so make sure you copy the attributes. Let's just do all. I think by default it's all. So there we go. Okay, so now we can actually see a little bit better what's happening. Nice. Okay, so that's giving me a pretty nice result. Cool, so one thing I might want to do, let's just zoom in and see how, yeah, so the collisions are working. The bananas are looking great. Okay, awesome. Something I probably want to do is I want to add a little bit of drag. So let's put down pop drag. Oh, come on. Pop drag and pop drag spin. So let's put the pop, we can just put them here and here. So pop drag, let's bring the air resistance down to 0.5. Oops, 0.5. And then the pop drag spin, I think I want like the spin resistance to be 0.05. So I think these are numbers that I just remember from the last version. They're just arbitrary numbers that I think worked pretty well. Okay, the other thing that I'd like to do is I want to create, I think, another collider to sort of push these up a little bit. So if we come to our out collider here, let's just template it. And then let's put down a grid. So, okay, I've got my collider templated. Let's bring my grid, or let's make it a little smaller so that it's like just a little bigger than this. Let's give it like 200 rows, 200 columns, and let's drop down a mountain SOP so we can kind of move this around. And I want the fractal, I want the roughness to be like 0. I don't want it to have that many octaves. Let's bring the element size down just a bit and the amplitude down just a bit. So what I'm going to have this do is sort of have this push the bananas upwards to create this sort of hilly motion along with the velocity that I've created. So if I click on animation and hit play, you can see it's animating. I think I probably want it to be like a pulse duration of 2, so it's a little slower, something like that. Okay, and then let's hit space 3 on the keyboard, drop down to transform, and bring this down below the collider. And then let's animate it so that at frame 1, it's down below the collider. And then at like frame 36, we animate it so that it comes up like this and kind of pushes these bananas upwards to create some extra little like hills and stuff. And maybe I want this to even be just, the amplitude to be just a little taller. So like that. So let's see how that works. Okay, and then let's put down, let's just drop out collider 1 here, get rid of these things. So we'll have another collider, copy that. We'll come in to our DOPNet. Let's put down another static object. We can just copy this. Actually, no, I don't want to copy that because it's got a bunch of stupid settings on there that get out of here. Get the fuck out of here. All right, static object, we'll paste our new path for the collider. Let's plug this, oh, I'm on frame 3, that's why it's calculating. Plug this in here, hit Shift R a few times so that this rigid body solver aligns to the right side. And then for this, we want to, I want to increase the friction a bunch because I don't want this to, and decrease the bounce a little bit. Now I can leave it at 0.5. And then I want to make sure I use deforming geometry so that it'll actually animate. Okay, so let's go up and let's see what we get. Hit transform pieces and let's see how this is working. Let me just run a little flip book. See what happens. Okay, so I've got this thing working. You can kind of see what it's doing here. It's doing what I want. A few things that I changed, that you're definitely going to need to change. In your static object that is this new collider, make sure that you change this from convex hull to concave. Otherwise, it will treat this whole thing like this big solid surface and just push everything up at once, and it won't like get these little dips. Something else, I took off the pop drag. I didn't like it, but I left the pop drag spin. And then in the pop advect volumes, I changed this from trace midpoint back to single step, and I changed the velocity scale just to 1. But those are just numbers. These are arbitrary numbers. Play around with them, get something you like. So basically, now that we have our simulation, what we can do is, let me just grab these guys and copy it. And then instead of using this banana out low, let me grab these and put the high poly banana in there. So now we have 2 of the exact same thing. We have, like, if we zoom in close, this is our nice high res banana and our low res banana. So we're going to be simulating with the low res banana, but then what we do is use this transform pieces to switch them out at the end. So it saves a ton of memory because you're not having to simulate with this super high res geometry. You're simulating with this crappy low res one, and then just caching only the points, and then you use this transform pieces at the end to basically copy the high res geometry back onto the points. So something you want to do is just put down a file cache, and we can you want to cache out the points here. So just the points like this. And I think I only need delete channels. I only want like 240 frames. And then probably before you cache this out, you may want to come back up here and increase this back to 5 and 5, and then go back into your DOPNet and go to the particle motion or the volume motion, go 5.1, 5.1. I was just doing 3 to make this run faster for the purposes of our tutorial here. And then let's make sure that our collider matches up. So let's go spacebar 2 to show from the top, and let's go back to our collider, and let's just make sure that there aren't going to be any more collisions on the sides. So the sides are looking pretty good. Let's go spacebar 3. Cool. There's this one down here. That's so weird. I don't know what that's about, but fuck them. Okay, so we can cache that out and come back in a sec. But something else I want to show you. If you notice in my little flipbook here, there's these little, the advection creates these holes. It's like blowing away a lot of the bananas, and you're kind of seeing through this layer through the bottom. So in order to fix that, or to at least cover it up, something I did, a little trick, was I took my collider here, this guy, and I put down a transform, and let's see, let's template these here, and I think what I want to do is I want to use a copy to points, like, let's see, I think I'll just take these here, take out the high res one, and use a copy to points here. So, and then let's just decrease the size of this so that it matches roughly with these ones. Well, actually, why don't we do this after we cache it? But basically what I'm going to do is I'm going to copy a bunch of points to this grid here, and then kind of match up the look, and then I'm just going to transform this whole thing down a little bit underneath our simulation so that it covers up the holes. So like when you look through the holes, you'll still see a bunch of bananas. And it's just kind of a cheap trick to cover up the holes. But first, let me just cache my simulation first, and then we'll come back and do this. Okay, so I've cached this out, and I ran a little quick flipbook just to see what's happening, and it is doing exactly what I want. Great. So it's obviously moving, it's moving the way I want, but it's moving like way too fast. So what we can do, let me X out of this here, we can retime this. So we can just put down a retime node and put this after the points here. And then let's make sure our input frame range is, input frame range is 240, which is what I originally cached. I think I only did, 240. And then I want to bring this down to like 0.1. For the interpolation, make sure this is on subdivision and that you scale velocities. If you don't do subdivision, you're going to get a lot of like blinking in your color. So now let's try this. Let me go back. I had a little camera set up here. So let's just run another flipbook and see what that looks like. Okay, so you can see now the retime worked. It's moving really slow. You can change the speed to be whatever you want. It's really simple. So now it looks super fluid and splashy and slow. Great. So now that you have that, let me come back to showing you how to kind of cover up those holes. So let me come to a spot where there's a hole. So something like that. I'd like to cover that stuff up so you don't have like plain air peeking out from beneath it. So let's take what I created before and merge these. And let's just, the other thing I'm going to need to do is to take this retime. And I'm going to need to retime the animation of my collider here so that it matches up. Great. So that looks about right, actually. Let's move these, let's transform this down just a bit more. Like that, maybe? So that it's not super intersecting. Let's make sure our copy to points, we got packed an instance on. Oh, maybe we can move it up just a bit. Let's see. I don't want these to intersect with the ones that are on the bottom, just kind of be below it. It's okay if there's a few intersections because you're not really going to notice it. But now you have this thing covering them up. So when it moves, when we position a camera, we can position one like really low or something right here. You're not gonna have just like light shining through here. It'll feel like there's way more bananas moving than there actually are, even though only the surface is moving. So that's pretty much it. Let's put down a null. Let's call this out bananas. That's pretty much it for this part, and then we'll come back and I'll show you guys how to light and texture it all in Redshift. But yeah, hope that is helpful.